Ladies and gentlemen, in this room and at home and in your offices at the screens, for the second talk of this afternoon, please welcome Dr. Veit Appelt, lecturer in the BIM topic at the Faculty of Transport and Traffic Sciences, Friedrich List Technical University, Dresden. He is also the CEO of A+S Consult GmbH. The topic of his talk is building information modeling, BIM, in planning, construction, and operation of railway infrastructure. So I think we'll have enough opportunity to discuss the choice of topic afterwards, so I won't say anything right now, apart from thanks a lot for joining us, and ladies and gentlemen, please give a warm welcome applause to Dr. Appelt, including me.
Good afternoon, ladies and gentlemen. I would like to introduce you to the topic of BIM in traffic infrastructure. We call it in Germany infrastructure information modeling because it is a special field. My name is Veit Appelt. Just to give you a short introduction of myself, of my CV, I hold a doctoral degree for engineering in Germany, a PhD, following to a diploma of transportation bridge construction and additional in IT from the Technical University of Dresden. I'm also a lieutenant of rail and road infrastructure, pioneer so-called, which is important for me. So we also know the subject of destruction in the life cycle, not just the planning and the construction. Today, I would give you two topics. It's a short insight about the lecturing at the Technical University for our students, the new generation, which shall deal with BIM. And we at the Technical University in Dresden, which is, by the way, one of the exclusive German Club of Excellence University and has the biggest transport faculty in Germany, are dealing with collaboration with several universities, as for an example, the Technical University of Munich, the Ruhr University, Bochum, and a lot more, because the topic is very special and needs a lot of experts to come to an optimization of infrastructure design and construction. At the university, we have lectures as well as seminars, which are close combined. You can see on the top also a screen of the lecturing as it is during Corona conditions. We have online as well as we have a special server for our students to come to deal with their examples, which they have to examine at the end. So the students are dealing on the one hand side with the knowledge in a more abstract way. On the other hand side, they have to do their own railway or road projects because we brought them together as both as infrastructure, and we have both at the Faculty of Transport. Additionally, our students are educated to get at the end the International Building Smart Certificate. We have a major branch here in Germany and also in the city of Dresden, where the German chapter is situated close to the university, and we are responsible even for infrastructure questions. To give you a short insight, I will show you also a little bit the practice which our students get. We have a kind of 4 subdivided entities which we are introducing and examining with practicing with our students. The first one is the foundational knowledge. You know, this topic is very close to math and IT. It also has a new kind of technical language that has to be combined with our old engineering language, which comes since the beginning of railways in 1850s here in Germany. And of course, we have also to develop a kind of data competence, which is very important, additional to the classical engineering knowledge, which often mounts to drawings about the projects. Now we have models, not 3D models, we have 5D models and more. The second part is dedicated to digital twin. The digital twin, which describes all the surroundings we need to design, to construct infrastructure. This is a huge bunch of data which we can get from international open sources. And we have additional, of course, a wide range of German specialized and in a special manner prepared data. But these are authors which are dealing with this, which are coming from geodetical authorities, providing, for an example, this area photographs, providing the city models and so on. And our task is really to deal technically and in the communication and in the process of legal approval, detailed design, tendering, with all this data and to bring it together to one common overall model, which is the main subject, the process of BIM. So digital twin is very important and is, by the way, also the base for artificial intelligence use, as we have started in Germany. So we can say the digital twin and the design and construction are talking to each other. The third subdivision is design and tendering preparation, where we have the preliminary design, detailed design, and the preparation of tender documentation and the construction contract as well, with all the legal frameworks inside and connected to it. And is of course our target to have these design models not just to be used for design. We want to take the same model into a construction, and we want to use the same model for maintenance. So once more, the life cycle, which is important for our students, and to add also special aspects which are used even for construction as construction technology, time scheduling, dynamic adaptation to the real situation, and then to bring it to maintenance systems such as SAP in Germany, where you have the whole infrastructure which has to be maintained. And we, of course, we want to see always the costs, not just for design and construction, but much more for maintenance on the long run. Just to give you a short idea and to show you how this looks like.
VIA-IMC is the innovation platform from Vinci and Eurovia. We are dealing with new technologies like artificial intelligence and building information modeling. Building information modeling will dramatically change our way we work in the future. Now we are dealing with big data, with open geodata, we are dealing with point cloud.
Sorry, but we cannot see the video on our side.
You can't see the video, so we try it once more.
You see the map though.
Yeah, the map.
Oh, you see the map, okay. So now it's better?
Right.
Yeah, now there's the video. Yeah.
Okay. So you can see my colleagues from the Technical University during the seminars, and you can get a short introduction about the dealing of the students nowadays with building information modeling, fitting together the elements of the digital twin. And you can see a situation of a typical German city where they have to construct a bypass as a road or as a railway bypass, including also bridges and tunnels. The basic data that we have can be also taken not just from German authorities. Of course, they are also available in open system internationally. So we have also a lot of companies dealing in international projects. They can use this. You can see the linkage to the GIS data which are available. And the big advantage of this technology is, as we see them, that the adaptation to newer data, to the last author additional input is always available. So we don't have fixed static systems as we can often see. If there is a change, for an example, in the property map, for an example, then you can see it. Also very important, I think, even if we have this change ahead to BIM, the integration of the old drawings. This means transformation to the systems, but also the intelligence, artificial intelligence-based extraction of data, which are important for us, even for the railways. So I think things like catenary or things like signaling, and of course the type-wise integration of things which are important for earthworks, for example, pictures and so on. So you see a big common data model which the students are fitting together. You see a wide variety of data. We have environmental data. We just saw noise protection data. You can also see that the principle is that we have a flexible model. This means it adapts itself to the digital twin. And of course, we always have changes to adapt the model to a better and higher quality. We have subsoil models with the students as well. And the subsoil models are, of course, directly connected to the infrastructure project. So you can get earthwork things, and this is always then the detailed design connected dynamically to tendering preparation, which is a huge advantage as you have all claiming on the construction side together with the contract which was signed in the very beginning. The students are dealing with libraries, open library systems, or special national libraries as we have in Germany. And of course, they have to use a wide range of interfaces to be later on in practice able to update or to integrate the already existing systems into the planning. So the education has a lot. We will see then a short overview about the software landscape, which they are used, and the most important are the interfaces, how to bring this all together. So this is a project which lasts for about 15 seminars. At the end, they have also homeworks and homeschooling. They can, of course, extend it if they think. And this is a good chance because in the exam, we give the students the possibility to present their projects. And the better it is, the better are the chances to have good or very good or an excellent at the end of the day for the students, which is a motivation as well as the possibility to get our certificates from the university. Of course, there is a high need, I don't want to say a lack, of the younger generations, which has to be educated in a new way. So at technical university, we have still the classical approach. Just give me a second because we see some technical problems occur because we had to change our hardware constellation, which we had planned. So this is about the education. Let me now, after this short few insight, come to building information modeling in Germany. Germany has taken position not as a front runner, where we had been waiting a time, but the more as a technical expert. So in Germany, we decided to use methodologies like BIM even before. But we decided to step into even to the international BIM process in 2015, even targeted to also shape the international guidelines, the European guidelines, and not just on the national level, and to use our technical knowledge as we think we have to contribute something good for this. In 2015, we had the conclusion of the so-called Reform Commission of Germany, because we have now a huge investment program of several 100 billion in the coming 10 years, which is being designed and constructed. And of course, BIM is one element. The conclusions were that we in the future have to be more cooperative planning in teams, that we have to plan first and then to build what we have before checked virtually, to introduce a risk management which has to be updated regularly based. It's even time and cost related, to give contracts not to the most cheap but to the most economical on the long run. We are in the infrastructure investment. We have to look at the long run. Maintenance costs money, and we have to include this, not just to have a look about just cheap planning or cheap construction. The cooperation in a partnership system is already being established, which is a cultural change which seems to be quite difficult even for the contractors. From the construction side, it is not so easy. We have dispute settlement council, which is able to pre-clear as a clearing point every disputes which occurs during design, construction, or commissioning. And of course, once more, we have the feasibility, we have exposés in the very beginning in the German Transport Master Plan to adapt them closer and closer to the project that is finally being constructed. Greater transparency and control, and exceptional mentioned in this plan was the overall use for these topics of building information modeling, and the decision was made not to use it just for construction of building information modeling, but to use it for infrastructure as well, infrastructure information modeling. So this cultural shift towards a holistic, systemic, and partnership approach is on the way. And of course, we have had to test it with typical building information modeling projects where several use cases have been performed. And this pilot project, I will give you a short map about Germany, showed, of course, also the basics as we have the special requests of the clients. We have the execution plan on site or during design, which is very important to have the possibility to influence it in a proper manner from the side of the public authority which invests the money. So building information modeling in the transport sector as well was the first big conclusions. So Germany had a look at the projects that have already been performed. Some of them even constructed. Here is just a little example of this. So these were also huge projects. We had a time span of about 10 years where we are used to have smaller projects like 10 kilometers. Now in Germany, we have typical sizes of 50, 80, 90 for the road and rail infrastructure. On the left-hand side in the top is a project for a high-speed railway. I will introduce to you then with a little video of 60 kilometers, this future speed in a mixture, passenger transport more than 300 kilometers an hour, and then the freight transport even in the night hours to be used. So this is a special German things. We don't hold separated infrastructures for passenger transport. High speed, as one example in Japan, we have always this mixture to use it also in the night hours. We have the first BIM project in the city of Leipzig. We have here, for an example, a project about 70–80% through the most dense settled area of Germany, North Rhine-Westphalia, which comes to the Netherlands borderline. And of course, we also had the Autobahn projects. Here's one in the north of Stuttgart, 60 kilometers on the borderline between Switzerland and Germany. And one of the very beginnings of the use of BIM was the German Transport Master Plan in the year 2013, where the exposés are all based on 5D models. So it means all the costs have to be continuously adapted to conditions. Frankfurt main station, we will have also a look in huge freight nodes as in the city of Halle, close to the city of Leipzig, which is a traffic node in Germany, and also in the north, like Hamburg and Bremen, you can see the tunnel crossings through the rivers. So these projects have been analyzed, and to get best practice and even to see the problems of legislation in Germany, technical guidelines, and to compare it with the international experience, which we can see coming for an example as UK example. Often they use London Paddington, everybody knows this film, but there's also the BIM project in the station, which is an extension of an old railway station. And this had been analyzed, and we shaped big variety of different projects and use cases. Just to have a look to the city tunnel of Leipzig. So I hope it's an old film, yeah, it's 2008, 2009. So we can see a whole tunnel construction which opens such a close station as they are used in Germany or in the whole Europe, and this is the biggest of the so-called dead-end stations, and it is to open it on the other side to the passenger traffic. So the passenger traffic is also used for regional traffic. Here you have a kind of PR usage of the 3D model, but I can promise you that each part you can see, if it is the lightning, if you see architectural elements, you can see the stairs upstairs is in a 3D model, and all the quantities and everything which has been used here, you can even see the tunnel construction. Every piece has a number, every piece has the concrete production certificate. Every piece has the transportation certificate, which is all settled there. And even if occur quality problems, you are able to check it after now already 7-8 years, which makes sense because the engineers which participated in the project have already in favor of their pensions now. And of course, you don't know, as it is typically the for an example, the cable, the subsoil conditions, the subsoil water conditions, and so on, which is all in the model and which is all connected to the documentation, which are several thousands of drawings which are connected to this 3D model. So this is the first BIM projects. The heads of the BIM projects are now also the heads of the infrastructure installation modeling in our Autobahn society for the federal roads and in the railways. And we, as the company where I'm the CEO, which provided over 10 years this common overall model, we are also in the business integrated and the technical university, of course, providing the knowledge of the university and to bring it in science and structures. Our German engineers, of course, we are speaking about German state-of-the-art and science, are used to develop this in a technical way. So maybe the visualization that you have seen in this tunnel project in Leipzig is already quite good, looks already quite detailed. What we have developed since is a substructure which is very close to the different trades that we can find in railways. I think you can see the equipment for an example here. You have a combination of a station projects with building and the combination of a typical railway section. This is connected to the station. And you can see all the substructure, all the specialist objects, which are already in a common language, in a common content of the engineer's language, of the math and IT language inside with a good documentation, and which we are using here. Once more, a short film. So I think so. You have the existing situation now. You know all this stuff using laser points and so on, which are quite stupid, and not we have to bring to intelligent model where everything is defined, and then. Just to give a short first impression to the data model, which is most important because the geometrical data we are considering are based on the data as well. There is no separate world of the geometrical data. Everything is digital. And here you can see the existing station combined with the planning for the new station. You can also see subsoil, the supply lines inside the platforms. You can also see all the detailed things which comes from libraries, which are individual, and at the final end, everything is connected to the construction as built model. And this is a project where the station is being reconstructed, extended, and adapted to normal contemporary needs in a time period of 7 years, and is also connected to the neighborhood stations, which are also under construction. And this is our biggest and most dense region we have. This is North Rhine-Westphalia with about 17, 18 million people living there. There is one big city close to another. You can even distinguish where the borderline between the cities is. And so we have a row of stations which have to be combined now. That's why the 7 years. So far for a first impression about the contemporary situation as it looked like, but I would like to explain also the BIM implementation, because the technical side is one thing, the other thing is really the challenge that we get from the cultural way, even from the integration of the engineers, and even also to avoid a government of math and IT, which also makes sense because railways is always very close to engineering, and we have to find the right mixture between these team members. So the BIM phased plan in 2015, introduced by our Ministry of Transportation and Digital Infrastructure, defines that from 2020 it starts that all railway projects have to be done using the methodology of infrastructure information modeling. So there are some core conditions which are in this phased plan. All information has to be contained in the overall model. We are constructing everything in 3D, 5D, and the drawings are just a result out of the model, not in the opposite. We don't model things from a 2D model. We have dynamic generated models, and the drawings is something like one of the possible results which you get in real time out of the model. The specialist models have to be combined, so it means the catenary designer, the signaling designer, or on the construction side, the specialized companies, for example, for supply lines or for the preparation of special foundations of bridges, have their specialist models and their specialist informations which come in a dynamic way in real time all together in a model which is available on site, and which is being used also during construction process. There are non-proprietary data formats. They are open. They don't rely on systems like Autodesk, also not on national systems. Everything has to be open to guarantee a data exchange and the possibility to include other contractors in a competition way. So this is the plan, the 3 steps. I would like to introduce to you now the map of the pilots we have seen. The first pilot stage on the left-hand side you can see was the start. On the right-hand side, this was the extension of the project you can see, and red dot means railways, blue dot waterways, and the greenish is the road projects. So this is quite a lot of projects, and of course there was a need for accompanying this, to analyze this, and to make a common outcome of this. So we had, even in 2013, in the analysis phase, we had a commission for the structural construction. This means even buildings, which made a first contribution in an analysis about the international and the German market. In 2015, you can see the point here, we had introduced the phased plan for digital planning, which provided all the financing from the German government. In 2018, we had a scientific backing, even with the extended pilot projects, with a pilot report, recommended actions. And since 2020, in this year, we have the organization of BIM Deutschland or BIM Germany, which includes, you can see here this, BIM, the universities, all infrastructure entities. This means authorities, construction companies, bigger design players as well. I already mentioned the Building Smart. Building Smart is an organization which is based in London and is an international one, has a big branch here in Germany. very close to our university here in Dresden, and they are dealing especially with the field of industrial foundation classes, which means a standardized interface, which shall be also accessible for infrastructure. And there's a big problem if you have a look at the situation at the moment. We have several IFC interfaces, which can be used for building information modeling, but not for our infrastructure and not for the extent of data that we have. So IFC 5, which is a new situation, maybe brings structures that can be used for preliminary design or design, but we are far away from detailed design or from construction and maintenance. But this is the first step and is being supported, for an example, for our partner, the Technical University of Munich. So the evaluation of the BIM phase plan is going ahead, and German's railways looks in the future like this. So we had the convergence phase, which is successfully finalized. At the moment, we have to build up digital competence. This means engineering enriched by knowledge of IT and math, based on this common language we have already found out. And we are looking in the future to see in 2025, already now starting the digital transformation. Finally, at the end, we expect to have also on construction side, even not a tablet, but to have a mobile telephone and an AR glasses, for an example, to see all the project data and to speak with the project data, with the maintenance data. So this, we think, is the way in the future, and we are dealing very intensively in Germany. So the building, the BIM Deutschland, here you can see the logo on the top hand, is also very detailed dealing, and they are dealing together for roads, rails, infrastructure now, attending to this club of BIM Deutschland, also the energy infrastructure. Maybe one of you knows that we also have a huge investment program for the updating of our energy supply lines. There are projects about several thousands to make usable, for one example, wind energy in the north to the south, and so on. So, and these are the detailed plans as they are introduced in all the authorities which are working together, BIM-like, in a team. The cultural shift, which requires a change management, is with the craftsmen. The craftsmen are designers, or the engineers on the construction side, or the constructors itself, or the people which maintain railways and railway station. And everybody should be aware of this, that there will be a resistance in the beginning, even a denial, and this acceptance can just be reached finally if we can show that it has positive aspects. So BIM, to do BIM just to have BIM doesn't make sense. You should really find out targets, and the target in Germany to be faster, to be more efficient in the financial way, and to see problems more in before, not to solve problems, to foresee them, and also to have really a nice circumstances for the everyday's works for everybody in the chain, and to have all the informations available if you are qualified to deal with them. So recognition of the problem and integration is a thing everybody should be aware, and of course even to recognize, to put the perception of the reality is a thing which is very important in the very beginning. You cannot go too much straightforward, and all the engineers are denying, saying, no, it doesn't make sense, we have done it since 150 years, it is working, why should we change anything? This is a thing which is even a cultural thing. It makes it a little bit complicated if you look to the language that we can find, and there are a lot of new words which come to the engineers, which they have to understand, come from math, IT. The contents are sometimes totally different, and the wording and the names are quite similar. This is very dangerous because we often see one engineer speaking about one thing and one IT specialist dealing with completely other things. So you can see here the tower building of Babel. At the end, nobody could understand the language of the other. This is something we have to avoid, and is, as the cultural change, a very important thing that has to be recognized. So you can have the definitions in a written way, you can have something like a book where you explain everything, but it must be in the brains of the people and to be really ready through the collaboration in teams. Another obstacle that we have identified in the beginning, this is maybe also a German problem, is that we have on the one hand side the art of engineering, as we know, or versus the Anglo-Saxon practice, which comes from US and UK. We already know the physics standards, which is spread over the world, but the wording even and the kind of work is a little bit different. So here typically we have contracts in the UK with data drops. We have typically the stepwise development of the project. In Germany, we know this continuous communication to work with all power to optimize a project in every kind and potentially to have then a 100 years use of infrastructure once it is built. This may be a problem as well. These are the soft skills. The soft skills are very much highlighted at the moment. We hear speaking then about communication, teamworks, but you can do nothing without data knowledge. This is a fact. So we have to identify people which have both the engineering knowledge and the math IT knowledge. This is very important. And then we have always the American slogan, keep it simple. Maybe you can keep it also too simple. It is not that simple. Everyone who comes from the various ways we have to operate these things. This must be reliable. So also with BIM, it is not just a side of this Lego building block. It is also not 3D to see a Lego building block. Of course, he is 3D, but it's not enough. If you connect data, this cannot be this simple data. The railway system for infrastructure information modeling, you can imagine like this, because we have entity relationship models, and entities described in geometry to add some parameters, length, left side, and so on, is not enough. We want, of course, that our signaling, our catering knows at which kilometer it is situated, which is the distance, how we want to know the conditions of the bridges, for an example, at a certain position, and so on. There is much more, and that's why it makes sense to have this common data knowledge. Often discussed during BIM, as you have also seen, 10D, 11D, and so on. No, the basic things, and we should be able first to handle them, is the 3D model. It's time technology. It's a thing which comes from the building construction. It doesn't make sense because, of course, we have the volumes directly from the 3D model. We don't have between them time, but we have explained it to our students. If you have technology, you have additional expenditures, you have additional technical problems, which finally mounts in the bill of quantity and have to be integrated as well. That's why 4D makes sense as the fourth dimension, and the fifth dimension is the quantities and then the costs. Germany, like typically, I would mention the 60 sustainability. We have integrated already the environmental issues. We also have other like noise protection seen in the short film and the maintenance, of course. So 4D seems to be a special thing. And I give you a short introduction to Leipzig main station, Frankfurt main station. So this is what is interesting for us. You can see the main station of Frankfurt. We have a subway there, we have tram lines connected, we have parking facilities, we have even a huge shop in the underground areas. We have 8 levels which have to be combined, and this is now under construction. 100 different projects fit together, even from the point of timeline and cost expectation. How to deal with that? It doesn't make sense to have an additional program. You have to change things. And of course, if you have problems, you cannot go back to the author system. That's why the decision was made to have an integrated system here. And the integration means you have about 120,000 objects which are designed and have to be changed during construction process in a time span, once more 7 years, a holy figure in Germany. And in this 7 years, you have to adapt step by step or level by level. And of course, also we have construction limitations for operations. Of course, you have several trades, like for one example, sprinklering, and you have to adapt this. So we have certain logical levels how to combine things, which cannot be done geometrically, which has to be a wide, quite more deeper logic. And you have to connect it to the timeline. And this project is also connected to SAP financing planning. So if you change, for example, a building section you want to execute maybe in the year 2024 for catenary or for building or for elevators, for example, then you can get it out of the model. You can see where it is. You can see how much it costs. And if you have conflicts there, time conflicts, for example, you have also the chance to not just to analyze the system and to have a clash detection, but also we have integrated a chance finder. A chance finder means it shows you a possible solution, how to come out of the math. And as the system is completely adaptive during construction, there are always changes. We need this flexible way, and we need this kind of infrastructure information modeling, which helps us really to solve the problem. So just a short introduction. So you have seen the examples. You can see also different traits here. We have seen also the clash detection and the chance finding. So what is BIM, what is BIM not? From our point of view, after all these pilot projects or after this 5 years research, BIM is not the digitalization of planning. I know people which mean if they have a PDF or a drawing from 1920, this is already digital. This is right, but this is not building or infrastructure information modeling. It doesn't also mean if you have handcrafted 3D models, this may be if you really don't have a library, if you really are not able to describe in a mathematical way the elements, but nobody nowadays would plan a cross section or something like this. If you have the chance to generate even this big distance as 100 kilometers with bridges and tunnels is being generated automatically. It is not a visualization. It is not a software solution at all, which is very big mistake, which come from the public relation of the big of software sales. And you have also to find out what is your national way. And it's no geometry fixed, handcrafted, but this is really a description, a logical description. So BIM is a parameter-based object-oriented data modeling in exchange. This is no loss of information. You can save this information. It is a linkage, very important, the relation, entity relation between the several traits of the model during design and construction maintenance. It should be reproducible definitions of modeling, evaluations. You should be able really to combine every logical fact you need out of the model. For an example, which catenary is being constructed in March and April 2024, how much does it cost me, which is the sub-delivery of elements, which is money of the construction company, for an example, just to give an idea about this. We have the consistent work in the entire overall model, and we have to have a complete versioning in history to go stepwise back. And if you go stepwise back, you must be clear if you have a model and you use software which is being updated on a monthly basis, where you can't go back to the old software version, then you will have a problem if you take a building information model which is 3 years old already. So you must also have to have the software which can go stepwise back, not to change the data. It's important. You lose a lot if you don't take it into consideration. The BIM process itself, you can see preliminary design, legal approval, detailed design, tendering, construction, commissioning, operation and maintenance. So it's enlightening of our expectations of the BIM process. And the BIM process itself, of course, once more cooperative working, overall model of the infrastructure and consistently managed the model during all these phases. One model for all phases. So a short impression from Bangkok as well and from Germany on the right-hand side. So we have the difference between building and infrastructure. Why shall be such a simple earthwork construction site, as we can see on the top, be more difficult than such a tall, beautiful building? The building we could adapt or see like a point just. We have big data, big distances. We have very big investments in maintenance. Then on this big distances, there will not be sit one and regularly go every day and to see in which condition it is. So we have really to manage to get the data automatically. We have continually to consider the changing environment. So soil, for an example, also environmental conditions we are influencing our project, like water, for an example, groundwater, and so on. We have the linearly parameterized design, which allows us to generate, for example, 100 kilometers and to adapt it during construction to see the bills, the quantities which have been constructed and so on. Once we have a generated model, and this could be similar if you have the prefactoring, but typically we have, even through the changing topography, the changing subsoil, already this change everything in our infrastructure project, and we are speaking about big amounts of money. Of course, we are in the public. We have public clients which should be able to present the conditions of a project, of the investment at every time, in real time, which condition we have, what we are doing at the moment. We have technical guidelines, we have legal framework we have to take into consideration, which is often quite more difficult and combined as we can find it on a private property building. We have life cycles which are long-term, and of course the investment shall be used over time span, if possible, without change 50, 100 years, all that we can see. So the conclusion is that the expected goal of BIM in the very beginning, even during pilot phase, it is cheaper, we need less staff, we need less time, doesn't come true. So even through piloting, we have to optimize this process, and the reality is you have to spend in the beginning more time, more stuff, more costs, but I can promise you, once you have done this, then you are much more efficient. So it takes you a 10th or a 5th of the time to make everything which can be automized or generated. So this is a huge progress, and that's why the conclusion is, also from the German side, it makes sense. So the life cycle is like this. And this is the most updated understanding of life cycle during BIM. It is the, you can see the circle now. I have my mouse here. You can see on the one hand side always the model in the center, then you have the design and the construction, which is not a thing itself. It is a necessary evil, I would describe, because finally we want to maintain and to earn money with our infrastructure. We want to provide infrastructure to our public so that they can find mobility. But technically it means we have the building information modeling here, and to bring it to the maintenance. We want to have a predictive maintenance. That's why we need a digital model as well. We have auto-optimized operation of our system. We have the data in the cloud. With a good connectivity, they are available everywhere. And we have a good sensoring and geodetic system which adapt always to the newest situation. So this is a life cycle which I think is a quite good description. Is of course already a little bit sophisticated, but this could be a life cycle for infrastructure and rail. So software landscape to do all these things. Which kind we need. We want to bring all the things together. You can see here, we call it our zoo of software. These are the animals inside. And they have more or less interfaces which are open or closed. And this is a big problem because you have maybe a 5 years project and you don't want to be dependent on just one. You have contracted design company, maybe you have several construction companies, maybe you want even a special construction company in a special field to contract, and that's why you have to be flexible. This flexibility you just get with interfaces. So you have the Anglo-Saxon systems, and typically you have the national systems. Once the data are digital available, you can find an access to a good building information modeling system. So we subdivided in open and closed BIM, and in little and big BIM. And of course, the nicest thing would be to have an open BIM system. This could be provided by a state or another untypical business model. This untypical business model we have found in the system of CoFin here in Germany as one possibility to have an open platform, and it is not just a national thing. Just to give you a short introduction, this is an international project. The biggest construction company of Europe is Eurovia, and in the competition of Building Smart International, it was chosen between 111 projects and was awarded as the most successful infrastructure project. This is the use of BIM on the construction site in the Vinci concern, which is maintaining, operating railways, roads, and airports worldwide. So, and here, of course, here you can see several things. This is available online. You can go to Building Smart International, and here you can see the award in the field of infrastructure project. This system is what we also use with our students in Germany. And just to step in a little bit to get an introduction for the project use, typically you have the modeling, as you have seen. For the digital twinning, you have to add all the data and to make the linkages between the data. Then you have the same data model extended by planning, by design, and finally to a construction. Then you have also tools for this kinds of visualization, communication, which is not a thing itself, it's just one of the possible results. It can be visualization in a three-dimensional way, it can be a drawing. So it gives the planning, which is very important for the cultural change. You have to be also connected to the additional kind of planning. So we have plan axes, we have longitudinal section, we have cross section, we have all the station data, we have the bridges, we have the tunnels, and we have the subsoil model. So everything is in one model together and is linked and calculated. And this was why we made the choice to have this and to use it in a lot of projects. But the conditions are really bring all the data together to an overall model, understandable interfaces, openly described, and also keep safe your national things you want to use also in the coming 50 years. So after the pilot phase, we have as well the client's information requirements. We have the infrastructure information modeling execution plan, in English BEP. We have to define the kind of modeling and the level of information need, level of detail, level of information. There are a lot of words that you have to bring together. You have also to find collaboration methodology. Where are the data? They are on the cloud. The cloud must be accessible for the client. The client should be able to handle it in everything. If he wants to hand over some issues which have to be changed, he has to be able to communicate in a very simple way based on the model. He should be able also to get his traditional plans and drawings to go to the institutions. You have a ticket system where you can control how the works are going ahead, and you should be also to have in stock a kind of libraries which are used to be able to maintain the systems with the real delivered spare parts. One word more to interfaces. So we have already highlighted that the first time a generation of industry foundation classes which is adapted to infrastructure need is being now developed. Of course, it is always not the super best standard because it is being discussed internationally with us in the European Union, in Germany, and the communication process takes always 1 year, 2 years, and at the end you do find these things which are accepted by the majority. So don't expect that IFC will cover all your needs and demands you have, but we will have it the first times. As it is a system you can extend yourself, IFC, you can also define your classes, you can also define things. It remains that you have no relations, which is very poor. You lose a lot using IFC. Hopefully this will go through in the coming 5-10 years. We can use these open data interfaces. There's also quite a lot. And you have the native interfaces. This would make sure that your software you are using now at the moment, or as we use now, can exist another 5-10 years and have time to adapt to building information modeling requirements and to infrastructure needs. And this is very important for the communications of your existing experienced engineers with the new generation, which is now coming up. So you can have the old systems providing author information, and you have the new system bringing them all together and making the add-on profit from a common overall model. Drawings. We in Germany, we think even for legal approval process, also for internal authority process, we will have, but they exist if you want on paper, or they exist virtually, for example, as a section, as a cross section, a longitudinal section, or as a 3D model section, wherever you want. So we have the process of standardization. If I take now my time of 50 minutes, I come to an end. We have the norms, the standardization. Just to show you as it looks like in Germany, you have the European level, you have the German level, and we have, of course, the recommendation which comes from the engineers organization. This is the Verein Deutscher Ingenieure. And we have Building Smart to have a connection to international requirements. This is a necessary thing. Taking into consideration that we don't want to have static models which look nice, but we want to have data models, which you can see on the right-hand side. You have to add even this data competence things, and you have to avoid that you close the market for just a few players which are able to deal with that. This is also dangerous from our German point of view. If you go to just 1 or 2 software providers, you have a variety. And you have to exclude just a model handcrafting. Even in infrastructure, you need additional types of generation of linear models to be successful. This looks then like this. Here you can see all the typical traits we find. We have catenary, we have the signaling, we have environments, we have structures, bridges, tunnels, we have this axis-related data, and everything, and this is much important to come to the conclusion, is we have a single truth model. We have no copies in the model, so we have always the most up-to-date state integrated in the models, and we are able to see it in just the engineer view, because the wording is also adapted between math, IT, and engineering, and we have a very open access to this data for everybody. Who is just dealing with one thing. You can always see it in the context of the other trades. Overall model. No, just to remember, no BIM 3D CAD, but 3D planning is very important in the strategy of infrastructure information modeling. So finally, I would show you a last film about infrastructure projects. This is 18 kilometers close to the city of Düsseldorf. Here you have flat topography and a connection which goes between Italy through the Alps in Switzerland to Germany, to the biggest European port of Rotterdam in the Netherlands, and also to have a connection to the big German ports of Bremen and Hamburg. And you can see here an extension of an existing lane, and you can see how detailed and how optimized everything is. You can see this road bridge, one example, which has to be reconstructed to a railway extension. You can see a third rail, and this was what looks quite simple. Kannst nicht sehen, bin ich noch wieder drauf? Kann ich draufdrücken? Björn, bin ich drauf? Ja. Ah, ja. So we come a little bit closer. So in the city, of course, typically it looks much more detailed, and you can see then every cable in the subsoil and so on. And this is a model that is in parts already constructed and is an as-built model and is a planning model. And you have the chance to get every information just using mobile phone or tablet and require the information you need for your special trade you are dealing with. So this is was just a short introduction of the German view of infrastructure information modeling. It is a mixture of practice and science. We have also seen the German strategy. We have seen huge projects which are already being managed with infrastructure information modeling. And we have seen the culture change. What is very important for the young generation, they are really keen on to work with this digital methodology. So it makes good sense to hand over our experience from the elder generation to the younger, because this will be their reality of work for the coming 10, 20, 30 works. So it will look like always you have all data connected and you have always all information ready, as we are used to use our mobile phone every day. Thank you very much. Now questioning and answering. If you have a question, I will try to respond. So please ask your question.
Hi, this is Chris from Siemens. I have two questions. If we look to a successful project in Germany, it's a VDE 8, right? We started planning 1990, and it was successfully and in time going into operation, I don't know, 2017. So a bit over 20 years. Fast forward 5 years, BIM model is interfaces are defined, models are defined. Do you have an idea if you could shorten such a project from the idea to the opening, and by how much? That's question one. And question two, when BIM really works, I see the possibility of automating the approvals. In a project that's 20 years, it's not just the first approval, there's tons of changes. So how do you see to move to AI approvals in authority? Is this possible? And what is your feeling on how long this takes the authority to think in that way?
Okay, thank you for your question. The first one, I know VDE 8. And I know this typical 20 years in Germany. I think the most of the time we spend in legal approval things if you have new sections. But even the reconstruction is complicated. This depends on the environmental issues that we have. I think the technical process, planning, and the technical approval can be done much more faster. We have now found at the moment technical regulations with the authority which is responsible for the technical approval of the plan, the so-called German-Deutsche Eisenbahn-Bundesamt, and to find interfaces with them to, for an example, to approve signaling, catenary things. This means the traits of planning. This can be, of course, be done in a much more shorter way. As far as the legal approval is concerned, I've shown or mentioned the example of about 60 kilometers, 300 kilometers in our high speed, and combined with freight. There we have already a 3-5 years discussion with all the authorities, which is now provided online. So it doesn't mean even this presence meeting during now even Corona and digitalization is much simpler, much quicker. So we are sitting together with 30 authorities discussing every issue, environmental issues. We also have, for example, the possibility to have information to all the people living in the area of the new project, to explain them why we choose one technical solution. And there we can see also that it is speeded up, but of course we have to provide much more information. You know, social media, once you have started, you get a lot of additional questions. They see much more details, as you can see yourself. So the technical process, for an example, if we see signaling, we have to go for Frankfurt in Germany typically to take out of the framework with Siemens, for an example, the considered number of signal, the type of signaling, the cabling and everything. This is a process that we can speed up. The legal approval depends always on national legislation. And there I see an obstacle or an advantage in Germany, because of course we find better solution from the point of environmental issues. The approval process technically inside with the EBA, you can always identify where the approval process is stopped at the moment, where the situations, which issues can be discussed. You can see all the discussed issues and are already answered in the documentation which is connected to the model. This will also speed up the process. So maybe a project like VD8 could be speed up to 10-15 years, depending on the legislation, because they are always able to get the updated project. They have always access to the newest technical features. And in the very beginning, we also thought, no, we don't show them the environmental basic data. We don't show them, for an example, the biotope mapping that we have. We don't discuss with them the spatial resistance to new infrastructure projects. This is now completely open. We even discuss it with the people living along them, because then before we have not an additional legal process, and if we have to go on trial finally, most of the questions are already answered, and that it goes step by step to the highest court and can be decided much more quickly than it is. So there is the big advantage of infrastructure information modeling from the technical view of view. You don't have sequential working one after another, but you have it parallel going. Everybody is working online at the same time. We have the Anglo-Saxons would call it the data drops, where you have one model combined with all the data, and we have a certain level of information which can be provided. Then this can be stamped officially by the authority. We are going forward to the next step. Already once more, working together. What comes additional is the huge communication process, because we're also transparent. I hope this is the answer for your question.
I would like to use this chance to say a big thank you to you, Dr. Appelt. A big thank you to Dr. Hietzschold, who connected us. And yeah, I'm pretty certain that you will sooner or later get more molestation from Thailand as a result from your talk today. Okay, thanks a lot.
Thank you. It was a pleasure for me, and I'm looking forward to come to Thailand. Thank you. Goodbye. Have a nice